Assalamualaikum and greetings to everyone. Hope you all in a good conditions. Hi, I am Shavika Wambazanam, a final year student from Faculty Applied Science. Today, I'm going to present my final year project, the synthesis of Betulinic acid 4-HYDROXY-3-METHOXYBENZALEDENE Hydrazone, and I am being supervised by Dr. Muhammad Tajuddin Muhammad Ali. First, let me introduce to you what is my project about. From my research background study, Betulinic acid is a natural product and diverse organic compounds produced by living organisms like fungi, bacteria, and plants. Betulinic acid is initially isolated from Gassiola officinalis exhibit potent anti-tumor effect, notably against melanoma, and shows promise against various cancer and viral infection like HIV. Birch trees are a prominent natural source of Betulinic acid. The probable statement for this project is by 2030, cancer deaths among those under 50 are projected to rise by 21%, reflecting a concerning trend in early onset cancer. The significance of study is Betulinic acid is being researched for its potential as a cancer treatment, not only for human but also in animal cancer models. Betulinic acid has demonstrated significant inhibition of tumor development and potent anti-cancer effect in laboratory study. Other than that, Betulinic acid derivatives exhibit diverse therapeutic potentials, including analgesic, anti-HIV, and anti-cancer properties, suggesting broader application in medicine. There are two objectives in this project. First, to synthesize Betulinic acid 4-hydroxy-3-methoxybenzaldehyde hydrazone, and second, to characterize the synthesized compound by using spectroscopic analysis. Now, let's jump to the literature review. As you can see, I have attached the figure of structure of Betulinic acid. At the left side is a basic structure, and at the right side is a structure with numbering. Betulinic acid or 3-B-hydroxylab 2029 and 28 oic acid, a pentacyclic triterpenoid of the lupine type. Chemical modification at sites C3, C20, and C28 of Betulinic acid 30 carbon skeleton offer opportunities to enhance biological function and develop potent derivative, particularly as an anti-cancer agent. Next is extraction of Betulinic acid. Betulinic acid can be extracted from Syzygium claviforum, Peltophorum africanum, and Cratoxylum arborescens that show inhibitory effect against HIV-1 replication, highlighting its potential for anti-HIV therapy. Apart from that, Dillenia indica, Altosiphon staminus, and Bicofia javanica also one of the sources for Betulinic acid that demonstrates cytotoxicity against various cancer cells, including colon cancer, leukemia, and liver tumors. For synthesis of Betulinic acid, the starting material is betulin. Betulin will go through oxidation and oxidize to betulinic acid. After that, it will go through reduction with propanol to obtain pure Betulinic acid. In this slide, there is one of a figure scheme of Betulinic acid derivative where it shows pyrazine derivative that is compound 31 from intermediate 30, created by oxidizing compound 1 with 2-hydroxybenzoic acid, followed by transformation with ethylene diamine and sulfur in morpholine. Thiazole derivative that is compound 32 and 33 obtained by brominating intermediate 30 with 5,5-dibromomaldryl acid, then heterosilazine with thiourea or thioacetamide in ethanol. Now we move to methodology. In this project, there are three main steps of synthesis. The first one is synthesis of Betulinic acid ester, reaction of esterification. In this synthesis, it starts with dissolution sample with diazomethane and then work up separation, product collection, and drying product with anhydrous sodium sulfate. TLC analysis also performed to check its purity. The second method is a synthesis of Betulinic acid hydrazine. This involved reduction reaction using hydrazine. The previous product was soaking in methanol and react with hydrazine. After that, TLC analysis performed. Initial separation with DCM, sodium chloride, and water was proceeded. After that, continue with column chromatography. The third and the last step is the synthesis of betulinic acid hydrazone or betulinic acid 4-hydroxy-3-methoxybenzaldehyde hydrazone. Start with preparation with betulinic acid hydrazine combined with a substitute benzaldehyde, which is vanillin, for hydroxy-3-methoxybenzaldehyde. After that, reflux and dissolution with methanol. Then do the TLC monitoring and solvent removal, and lastly, washing and purification product with diethyl ether. Final product was brought to further analysis using NMR. Now entering the result and discussion part. This is the reaction structure of betulinic acid ester. It is from betulinic acid to betulinic acid ester. This is 1H NMR spectrum of betulinic acid ester. From this spectrum, we can see the presence of SID-methyl group characteristic of pentacyclic terpene structure. Next is 13C NMR spectrum of betulinic acid ester. The result indicates the presence of 30 carbons of betulinic acid and also a new signal specified to the ester group. This scheme is a structural reaction from betulinic acid ester to betulinic acid hydrazine. This result shows 1H NMR spectrum of betulinic acid hydrazine. It shows additional peak due to the hydrazine moiety and a new peak reflect charges in proton. Next is 13C NMR spectrum of hydrazine. From the spectrum, it also shows additional peak due to the hydrazine moiety. New peak specific to hydrazine functional group also showing. This is the reaction scheme of from betulinic acid hydrazine to betulinic acid hydrazone. This result shows 1H NMR spectrum of betulinic acid hydrazone. From the result, it indicates the presence of elevated proton, which is methyl and methylene group. For the result, there is no NMR spectrum for 30C NMR spectrum of betulinic acid hydrazone. This figure shows the structure of the final product that we supposedly get, which is betulinic acid 4-hydroxy-3-methoxybenzaldehyde hydrazone. In a conclusion, the synthesis of betulinic acid ester, hydrazine, and hydrazone represent a major advance in medicinal chemistry, offering a potential for creating new compounds with enhanced biological activities. Betulinic acid ester was successfully synthesized and characterized using techniques like NMR, ensuring purity and structural integrity for drug development. Adding a hydrazine group to a betulinic acid improves solubility, stability, and interaction with biological target, making it promising for pharmacological studies and therapies. Further research is needed to explore their pharmacological activities, optimize synthesis method, and identify lead compound for clinical trials, paving the way for innovative medical treatment. Thank you for spending your time and lending your ears hearing my presentation. I am truly grateful for that. And not to forget, I also attach a few of references at the end of this video. Thank you, and I hope you have a good day.